Hello, I got a request solve this low shear bending diagram, and also trying to find the flexural bending stress on this geometry. I have a triangle, then you have a curved triangle inside. Then I think the rest of concept in terms of finding the maximum bending, everything is very clear. However, this problem, the true challenge lies on how to find the moment of inertia. I'm pretty sure you already have experienced. So it's geometry here. It's kind of how do I say? It is really kind of like tedious, and it is challenging. So let's work through that. So this video is just trying to solve the moment of inertia, which I believe that is the most hardest part of this problem. But I want you to pay attention. They said for the purpose of calculating the moment of inertia, use the simplified assumption that the centroid of a triangle hole in this middle is going to be the same as the centroid of the outer triangle. So that's going to help us just a little bit. Okay, so I'm going to start to draw this. I'm going to start to draw this triangle and see how we're going to solve it. Okay. Maybe I would just draw right here. I'll draw. So I'm actually going to exaggerating. I'm going to make a big triangle to prove the points. Let's see. And so that's going to be the outer triangle. Then we'll have the inner triangle. Okay. The reason I kind of exaggerating a little bit is I want to see something misconception we might have by looking at the smaller one. Let's go ahead and label them. So this is W, entire length is W, entire height is H, and the thickness T. So from here to here, that gives us H, and the thickness is T. Okay. Now, we know the dimension of the outer triangle, W and H. However, we don't know the base, and we don't know the height of this inner triangle. So let's go ahead and see. This is going to be X. X is what we are solving. And this is going to be our Y. We are solving this too. Okay. Because we know the general idea is going to be using 1/12 bigger triangle minus a smaller triangle. So 1WH cube minus 1/12 XY cube. So now the question lies in how do we find X and Y? So that's our goal. Now let's see how do we find Y first. Y is going to be from here to here, and we know this is T, and the entire height is H. So if we could go ahead and find this red line height, then we might have a clue, right? But now we're going to draw some supplementary line, construction line here to help us look at it. So tell me what this orange dashed line should be. Yes, they're going to be T because of thickness. So then, if I can find this angle, if we call it alpha, then we can find that hypotenuse red line. So how do we find alpha? I want you to look at this big triangle all together. So that alpha, basically, so if I were trying to look at this triangle, now we have alpha is going to be equal to inverse tangent of half W over entire height H. So alpha can be solved. That's our first step. Once alpha is solved, Now we're going to trying to look at the smaller triangle right here. Right. So for this smaller triangle, it's also a right triangle because this is 90 degrees. And we want to find this height. We're going to give it a value. We're going to give a symbol. What do we call it? F. Okay. So F is going to be equal to its hypotenuse. So it's going to be opposite T over sine alpha. Since you already know alpha in the first step, you know T, and you find your F. Now, it won't be hard for us to find this Y now, right? This inner triangle height. So we know we're going to pay attention to this entire height, so which will be H minus the thickness right here, T, then minus your F you calculated. That's going to help us to find Y. So that's good. Y is checked off. Now let's look at the X. I think X is a little bit more challenged. You might find some other ways to solve. I'm sure there are. Might be easier one. Now let's take a look at it. X. How do we solve it? If we were trying to extend our X, like, we're trying to extend that line. So can we find out the length of that line, that purple line? Right? I think we have idea how to solve that. If we're going to give a symbol for it, why don't we call it B? This entire purple line is gonna have a B. So then our step number 4. Now again, I want you to look at this yellow highlight of this triangle. We're gonna use that again. So if we do that, then I want you to think about proportionality. You have this, which is half W, then over this length, which will be half of the B. That's going to be equal to this height, this entire height, which is H, over height from here to here. What do we say? It's going to be entire height H minus T. So H minus T. Okay, so using proportionality, you can find out B. So you can solve B. All right. You solve the B, so you know this entire base will be. Now, we just need to go ahead, solve. We just need to go ahead and solve this green line, right? What would that be? So what would that be? And how do we solve it? So let's think about it. If I were to add some construction line here also, let's see if I draw that, because that's going to be, this black line is going to be the thickness, right? So that's going to be our T. So if that's a T, and do we know this angle? If we know that angle, like, we can find that green line. Let's think about it. All right, so this angle, let's go back here, that's alpha. If that angle is alpha, what do you think this angle should be? That's right, it's going to be 90 minus alpha, because this is a right triangle. If that angle is 90 minus alpha, this is again right triangle, this will have to be alpha. Oh, I think we found our way. Because if this angle is alpha, we can know this angle is the same identical angle. So knowing that, we can go ahead, solve our step 5, which is we're trying to find this, the green. Let's give a symbol. We have used what? F. Why don't we call this G? So G is hypotenuse. So it's going to be T, the thickness, which is adjacent, divided by cosine alpha. So you solved your G. Then the only thing we need to solve is the final thing here. This rainbow color, right? And this is what we call it. We're going to find X. What's X equal to? So step number, last step. X is going to be this entire length, which we already figure out is this purple. It's B minus 2 of the green, because that's symmetric. So that's the green also. Minus 2. The green is G. You figure out the G already. So that's your X. Finally, we got our X. And we also had our Y. So we get both of them checked off, and we can come back to figure out our moment of inertia for this geometry. That's it. I promise you the exam will not have any questions like that. And hopefully you'll have fun exploring this using your numbers. All right. Okay, take care. Bye.